Good afternoon. Thank you everyone for coming. My name is Ribal Najjar. I'm a solution architect with Comcast. Quick couple things about me that make sense in the context of this presentation. So I've been at Comcast for 13 years, done a few roles, but the couple relevant roles to this presentation are that I was part of the network team, and we worked on different things in the network, forecasting, modeling, BI, capturing data, analytics data from the network and analyzing it. And then at a future role, I started working with a video team, sourcing the quality of experience metrics from the IP players to try and measure the customer's experience. And so from that combination, along with a push from the org, stemmed an essence of that pretty much stemmed into this specific talk. So which is pretty much overlaying the network performance data on along with the IP video quality of experience metrics and seeing what we can do and learn out of that. And we'll talk about that a little bit in the next slide. So IP video streaming data and analytics, that's a pretty hot topic, right? People are analyzing the data for so many reasons: viewing, understanding the customers' engagement, understanding what are people watching, what are not watching, what's the performance of the underlying infrastructure, how to monetize it, so on and so forth, right? There's a whole bunch of applications. Ours is slightly different. Ours is focusing on a specific subset of that streaming data, which is quality experience metrics, and we'll talk what those are shortly, and trying to use that to improve the network's operations model and performance and improve the customer's experience. So with that said, a bunch of verbiage for the folks that want to read the slides at some later point, but that there's a very large very large volume of data that is being produced by by the video platforms, and there's an even bigger potentially data set from the network side, and then trying to overlay the two data sets on top of one another and trying to learn and infer and try to optimize based on those analysis. That obviously requires a whole bunch of advanced data analytics. And so what we will overview in this presentation is how we did this, what was the business logic. So we'll capture 3 or 4 high-level topics. One is we'll start by understanding how the current operations model work in an ISP, Comcast at a high level. Then we'll overview what QE metrics are for those that aren't familiar with them. We'll give some examples. And then we'll see how those quality of experience metrics can be leveraged in that network-oriented operational model. And so after that, we kind of overview what we did in that whole pipeline, so that if folks are interested in doing, they understand what the challenges are, what the process was, who was involved in that scope. And we'll go to a use case showcase showing a use case that we did and the findings from that use case. And then we'll talk about what are the implications and measurements of that. And then a quick glimpse into what we would like to do in the future and what we hope to do. So that said, we'll start by talking a little bit about the existing operational model and how it works. And so assume this is a video delivery pipeline for the sake of things. It's a bunch of autonomous systems that really work with one another, but are operationally independent of one another, and that's part of the power, right? That's how things scale. It's modular. You don't have core dependencies between the different components or subsystems of a pipeline. They have to work and function independently, separately well, right? So that we can scale and we can grow it. so subsequently, what happens is that each metric, each system is now measured and operationalized separately, and it has its own separate quality of service metrics, or metrics that are then analyzed and then drive the operational model. So it's somewhat of these verticals that you see going down that are independent of one another, yet they depend on one another, I guess, for lack of a better term. And so a couple other things, as you see, eventually when things get to the customer, if things aren't working, then the interface for measuring the quality of experience has been traditionally calls or tickets or customers raising things up if things fail. And so that's been kind of the essence of these QE metrics. So quick thing, like when we're able to produce these QE metrics from different systems in a reliable way, then that should be pretty interesting for us to try and see how we can capture those, right? As opposed to waiting for the customer to raise an issue. So I'm not gonna bore you too much with this, but it's important to kind of understand this just at a super high level, so that when we go back later to the QE metrics to see how that fits in this model. So currently, network operations and metrics, they've pretty much grown based on some rigorous analysis, some best practices, some SLAs, right? We know we need the signal to noise ratio to be between, above a certain range, or and so on and so forth. And sometimes they're done produced from lab testing. They're done from best practices in the industry, and so these are pretty rigorous thresholds that are there guiding the operational model. That then we take them, analyze them, build some ranking algorithm, optimize them, and go fix them and bring things back to normal. And so, in an essence, hoping to improve the customer experience or fix any issues with the customer. So, so what does that mean? How now we're talking about quality of experience metrics. That means customers. That means what the customer is feeling, what the customer is seeing. How does that fit into this previous slide that we talked about? Coming from analysis and very rigorous approach. And so before we get started, just quickly, for those that aren't familiar, what are quality of experience metrics, right? Not my definition, but makes perfect sense. So it's the degree of delight or annoyance of a user while watching, in this use case, while watching a video stream. And so it also touches on their perceived improvement or degradation. So yet another layer of, pretty hard to measure and try to get a sense of what it is. And then at the end of the day, it's the customer's or the viewer's satisfaction with the media experience. So, so it's obviously pretty hard to try and fetch a metric that gets to measure that. Thankfully, there are a bunch of working groups across the industry that are doing a lot of work trying to pull some information from the player and analyze and study what the customer's experience is. And so, for instance, rebuffering ratio, which I single out here, there's a whole bunch of other metrics that I can mention a few. Rebuffering ratio is the measure of what's the percent of the time that you're sitting watching your video and you're seeing the little wheel turning around and the video loading. So if you watched a 99-minute movie and you spent a minute looking at the wheel, the spinning wheel, that's about 1% rebuffering ratio, to give you an essence. And so industry standard is that 1%. That's bad. More than that, that's really bad. And so that's been done, some work has been done to try and measure what's a right threshold for taking this metric and trying to simulate what the customer's experience is. And obviously the customer's experience is going to vary from a person to another and from scenario to another, right? If you're watching on you're mobile, you might have a different set of experience if you're watching on your 4K, 70-inch TV. You have some expectations, and so things vary. But let's assume and all agree that like you don't want to look at more than a minute of the spinning wheel while you're watching a 99-minute movie. So a starting point, right? And that will change, and probably at some point in the future, we won't be okay with 2 seconds or 5 seconds, or maybe we're not already, or some of us aren't today. And so rebuffering ratio is a metric that we will base later the machine learning algorithm on. And so I single it out here. Other metrics are things like how long did the video take to start? If you're sitting there waiting for 10 seconds, that might not be acceptable to you, or and so on. And so these are some of the QA definitions. So there's some challenge in trying to pin those out and produce them and trying to quantify them to measure the customer experience. But that's a separate engineering task that has to be studied, analyzed, or maybe it's beyond engineering as well. So now that we know what QE metric is, in contrast to these QoS metrics or these network metrics that we looked at and mentioned, I didn't mention any of them, but like I mentioned signal to noise ratio, let's say, or error retransmission rates, and things like that. At first, when we started looking at this, we're like, there's nothing in common, right? Like, one thing is doing the quality, the network telemetry is measuring a specific component performance. It's very rigorous. We pull these metrics every minute, every 5 minutes. They're always there. They're independent of the consumer. So if you're not using your internet, these metrics are still being pulled and analyzed and alerted on if they go out of bound or whatever. And so and they're service agnostic, right? We build the network to accommodate for a whole bunch of use cases. It's not only video, right? A video of HSD, your high-speed data, your internet experience, your experience uploading your images to the cloud, your experience in downloading movies, watching YouTube, this and that, Skype calls, and so on. And so the network has to be to some degree service agnostic and work across different services. These quality of experience metrics are not. They're like, how do I feel about watching this video? 5 seconds later, I might be uploading my pictures and everything is perfect, right? I don't, And so they're very service agnostic. They're harder to quantify and qualify, and they measure things end to end, right? So if you're having a bad video experience, that could be anything. That could be anything in your pipeline. That could be your phone, your laptop. It could be the network. It could be your wireless network, your router. It could be the from the source, right? It could be so many different things versus the other very focused metric telemetry. And so when we started looking at this, we're like, this is somewhat orthogonal, but that's a great thing. This is pretty much is really complementary to with what we really do on a day in and day out, and it works. But maybe this can bring something new to the picture, along with a bunch of challenges that we have to solve for. So at a very high level, if we start thinking about millions of people starting and watching different video sessions, that's pretty powerful. You have now 1 million transactions testing your end-to-end pipeline and giving you data. So that's a super powerful data set. That's if we can operationalize, that's a big win. And so so what was the vision around that? So I had to have the cycle. That's a must. Measuring, analyzing, taking action, improving. That's something that you have to have as you're doing any proposal of what our vision is going to be. And so we wanted to leverage the QE metrics by kind of talked about that. so that we can extract operational insight and improve the customer experience. So we wanted to do that. So how does that look, right? I talked about it a little bit, but when you get on the drawing board, this thing that looked super simple in this little 4-quadrant cycle is now a pretty complicated approach that we have to solve for. And so we have the end-to-end pipeline, the home network, the devices, the delivery network, the CDN, the network in between. Each and every component has a whole bunch of telemetry that might be impacting or affecting the IP video quality experience. So when you start getting all these things that are network and operational metrics on the left-hand side, and trying to join that data or those data sets to IP video quality experience, you have a whole bunch of opportunities there. But those are really complex opportunities, right? And you can't, it's harder to measure them one at a time. You really have to take the whole package. Otherwise, you might be missing where the fault or impact is coming from. And so we wanted to define these metrics, build them, analyze them, and then measure, right? And hopefully improve the customer experience, not only for video, but also for not only for the network, but also for the customers watching the video experience. So we thought we could, that could be pretty powerful. That said, what I'm not going to spend a lot of time here, but now it started to say, so how do we do that, right? And so there were the obvious four or five tasks that you see on those horizontals. Well, one, we have to define those metrics, right? So there's a bunch of resources available, and we can kind of walk through building them. We talked about the rebuffering ratio one, but then there's the data engineering task. You have to go build them. You have to go source them, build them, and then you have to join that data to the network data, and then you have to build your data science, machine learning, whatever, big data analytics on top of all that, and then by the time you have some findings, that doesn't quantify to anything if you don't operationalize it. You have to operationalize it, and now you're saying, I have these findings. Let me go work with the operations team across all these previous verticals to try and see how I can optimize and fix things. And that's a pretty challenging task. And then you have the reporting, because if you don't measure it, you really and continuously improve it, you have to measure. And so this is kind of how the different tasks that looked that we had to tackle. And obviously the hardest ones are the data engineering tasks. That's a lot of work. And then the operations task, or getting the learning and trying to embed them in the existing operational process, that's also a challenging task. And so what I also have in here is kind of a preview of what were the approaches of what we're going to present next, which is first one is a fault isolation approach. So where is the fault in this larger pipeline happening? And then two, how do we take some of that a data network telemetry and leverage them to improve the operational system, right? That's another line there of actions shown in the orange color, and so that's really what we had to go through as we went through this. I missed a super important part, which is I really wanted to ask everyone to pretty much stop me when they have any questions, but I'm almost half the way through. But still valid. No need to wait till the Q&A. If there's something we can make it a lot more interactive, please.
How are you dealing with customer feedback on this? Right now, this looks all from your end as opposed from the customer end.
Yeah. So the customer feedback piece is already addressed in a whole bunch of other processes across the company, right? So we wanted to be super focused on how do we produce our own quality of experience metrics, independent of waiting for the customer to tell us about those feedback. That, all right. So so now to the case study. So pretty much kind of overviewed a little bit of what we're going to talk about, but a little bit of detail. So first thing is we wanted to predict. We wanted to try and build a model that can predict this rebuffering ratio. Given the network information and features that we give to the model, we wanted to see if the model can actually predict what the rebuffering ratio is, right? So that was the initial goal. And so some of the features that we used, and we had a bunch of different models that we worked on. And some of those models we worked on internally. Some other ones we worked with a third-party company, Conviva, to try and build some of those models as well. And so, in a simple way, it's rebuffering ratio as a function of any or some of those components that we looked at that are listed here. Your home network, your fiber node, service group, these are network elements that are in your path, in your video delivery path. CRAN as well, it's just the core network, and then CDN and so on. So first objective was to predict those. And so when we kind of a high level visual, but as we started to predict these buffering ratio, high buffering ratios, they would look something like this. We know that this video session had a high buffering ratio, and that's the path that it took, right? And this is a somewhat of a simplified view just to make a point. And so assume all these red lines going through the devices, the home network, the fiber nodes, the service groups. These are, again, these are just network components in between the home, between the device and the IP-CDN. And so now we have them. Now we can predict them. We built a model that can predict those. Random forest model. We tried boosted trees model, and Conviva had their own models as well that they provided. And so great. Now we can predict. So what's next, right? We haven't quantified. We haven't isolated where in this pipeline the issue is, right? That's what we're after. I mean, we obviously want to be able to measure and predict, but we don't want to. It's not enough to stop there. And so we wanted to understand where in that pipe is. And so objective 2 is fault isolation. So how do we understand if any of the components in the path of this video session between the device and the IP and the CDN is contributing to the degradation in the buffering, right? In the quality of experience. And so that's objective 2. And so what we did is, and this is really a super simplified view, is say you had an IP video session. In this case, it's ID1 that was on this specific fiber node. So out of if I go back, out of all these CDN service group, fiber node, home network, say we wanna evaluate if one of these fiber nodes is is responsible for some higher buffering ratio. And so this table kind of tries to address that. And so for this fiber node, say we predicted a rebuffer ratio of 3.5%. That's bad. And so and then we try to predict what would the rebuffering ratio be if we say fix this fiber node or replace it with a good one or whatever the method is. And so in this case we predict it to be 0.2%. So pretty much we can say that about 3.3% of that rebuffering ratio is because of that element in that red pipeline. And so that is a high level how the fault isolation model kind of worked. And so in this case, it says that node A is really responsible for the larger chunk of the rebuffering. And so going back to our previous model, now we say, this home network is responsible for a large contribution for all these viewing sessions represented by video streams represented by the red lines. And so we've pretty much been able to propose or predict a fault within the home network, right? Just to kind of make a point, another potential view could be that a certain device type, right? Like, a really old laptop or a really old phone or something, could be the source of this bad experiences, and that kind of shows that in the red boxes in the bottom. Now, obviously, there's no need to have 3 examples, but I wanted this because this is a segue into the next piece of the analysis. In this case, say we identified this fiber node, going back to this previous table. We said, okay, this fiber node seems to be driving some bad, some high ratio of buffering ratios, and so we isolated it. We think that's the one responsible for a lot of that, and so that's that, right? So now objective 3 is operationalizing this data. So now we know that we don't really know. We're predicting that a specific node is driving some bad quality of experience. So what do we do about it, right? And so so now we want to take that data and kind of join it with our playbook, operational playbook, to see how we can run the two together, right? And so this is at a super high level. As we built this fault tolerance, this fault isolation model, there's a whole bunch of, in this case, we're talking about fiber nodes. There's a lot of them in the network, and so when we look at buffering ratio across them, pretty much it looks good, right? The majority of them, if that's the first slide, the majority of them are right around 0. And there's a bunch of them on the right, and on a long tail there on the right, and and so when we look at the ones that were not identified by the fault model, pretty much the majority of these nodes are there. We're looking at a small data set that were identified by these models, and so obviously the third one is not to scale. The third chart is not to scale, but you can see, that buffering ratio across these fiber nodes, also having a long right tail, and it's obviously not at 0%, and so these kind of were the high level findings. So what do we do with that? We have this list of nodes on the right hand side, small list of nodes. We have to do something about that, right? Which here is not really machine learning at this point in time. It's closing that loop, right? It's that third and fourth quadrant and that cycle thing that we showed earlier. And so comes down to a practical use case. So we worked with the operations team, said, here's a list of fiber nodes that we see that might be correlated to bad video quality experience. Take a look at those, see what you can fix them, inspect them more. Are they on your, they might be on your list, they might not. And so they did that. And then we captured the impact of fixing these nodes on customer calls and on IP video on the rebuffering ratio after fixing them. And so the fourth objective was, okay, so now let's measure the improvement. So we fixed this list of nodes. Some of them were on your list already. Some of them they were not on your list. So what happened? So at a super high level, what's the business impact? So nodes that are not flagged by the machine learning model, ones that have less than 1% rebuffering ratio, when these nodes were fixed, didn't show a significant improvement in buffering ratio. Also, didn't show a, a decrease in calls. Right, things kind of stayed flat. When we looked at fiber nodes that were that had a buffering ratio greater than 1%, we saw that after fixing them, the overall we saw a decrease in the rebuffering ratio, and we saw a decrease in the call volume. Now that's a really small set, and we did this exercise once, and because a lot of this is manual, takes coordination, and so on, and that's part of the next steps of what we want to do. But we were kind of our expectations were somewhat met. We thought that that's a good step. That's a good thing we found, even though that's a small sample size, and we don't. It was significant within that sample size, but we want to do more to try and establish that. And so these were kind of obviously, hopefully that meant improvement in quality of experience of the customers, which is really what we're after. So now we did this. This is great. So what are our opportunities in those scenarios, right? We to kind of take a quick step back. Assume now for a second there are two lists. There's the list that is being produced by the machine learning model, saying here's some fiber nodes. Here's a bunch of fiber nodes. Go look at them. See if you can. See if you can fix anything in them, and then there's the list that actually exists in the hands of the operations team. That's what they do day in and day out. They take these nodes, they fix them, that's what they're doing. And so you kind of have these two lists, and there has to be some combination of the two that we can try and build around. And so in these are a couple use cases that can tie to potential opportunities and improvements in the operational model. So if the fiber node is on the repair list, and if the fiber node is flagged by the machine learning model, then that could be an opportunity for us to prioritize and say, what, we have confirmed degradation of customer experience, so these are really, really critical. Let's fix those first, right? Versus the telemetry of this node is saying that it's bad, right? Which is super valid, but still, that's just another added layer. And so that is one opportunity for us to amend our operational playbooks and leverage some of that data. And the other scenario is that, well, what if this node is not on the repair list, but it's on the machine learning model? And so now we can ask, is it rightful? Is that data really rightful? Is the machine learning model prediction accurate, and that's what's happening? And so if it is, then maybe we'll have an opportunity to either embed this metric in our QS-based model or improve on it. Maybe there's a metric or a threshold that we need to tweak. We set it to 10 and it should be 5. And so we can optimize our operational models in that way by leveraging the findings from here. And then maybe at some point we have a faster fault detection. So if these nodes are on the machine learning model, but they haven't transpired yet on the repair list, then we have an opportunity to really jumpstart that process. If they're rightfully there, jumpstart that process and get things done faster and in a better way. So we measured. We know what our next, what these next steps and value propositions for improving are. And so what's next, right? So pretty much the previous slide tells a little bit about our next steps. So obviously we want to tighten this. This was built on one, quality of experience metrics. In this case, it's rebuffering. There's a bunch of them in the IP video world. There's a bunch of them maybe that we can source that are not video related. And so, let's see what we can do. Let's better understand those relationships, right? So, how do they relate, and how can we tune these QS metrics to be to tell us a better story, say, and then from the super hopeful, in me at least, and what I think would be super valuable is that, so once we really understand what's happening, and maybe these are indeed predicting before we capture this in some other metrics, like if they're leading indicators to trouble, then that's great. Maybe we can have a predictive model that uses these QE metrics that can kind of help us automate and identify problems either before they happen or live as they happen. And so, I mean, pretty much as anything related to machine learning, there's a bunch of there's a lot of opportunities there that can be pursued. But that's kind of the next short-term and longer-term approaches for what we would like to do. Questions?
Yeah. So if you zoom out from the fiber node, so the congestion points, it could be coming from one of any number of passes that are overflowing, or router ports, or peering, or transit points, or a bunch of things that are happening. They're happening kind of higher up in the network, outside, north of the fiber node. Do you have visibility to be able to correlate that with purely issues, or is that one of the possible next steps?
So we didn't do that, and the fiber node is more of a passive, and that's a little bit of the detail. But since you asked, a fiber node is more of a passive device that kind of takes fiber and translates it to HFC, and so it doesn't really have a capacity or congestion point of view. It's just the health of that node and the signal to noise ratio and so on, the quality of the connection that dictates that. So we didn't really tackle that specific scenario specifically in our analysis, right? But we're still in our infancy, and that's we'll see where that goes.
When you isolated the source of issue, why did you pick the fiber node and not one of the others? I mean, you can have multiple dimensions there on your
Right.
silos, right?
Right. So and I should have repeated the question. So the question is, why did you just choose fiber node? And in theory, why did you only choose fiber node? And in theory, we're not just choosing fiber node. We're really choosing each and every one in that pipeline, but we're testing to see which one is significantly impacting the end label, which is the IP video, the rebuffering ratio. And so in this case, what we said is that there's a bunch of video streams that crossed through this fiber node and had the high rebuffering ratio, and so the model flagged that as a significant driver of that. And so once we've ran that on all the existing paths that exist, then we can say, here's a list of fiber nodes that we think are, that the model is flagging, right?
Still, the problem could be multi-domain.
It could.
It could be coming from the fiber node, but also when you isolated the device itself.
Yes.
That could be a problem also
Yes.
with devices like X.
Yes.
Do you need to visualize all functions?
Yeah. That's actually now I see your point better. So in my example, in that one table example, I said it's 3.5%, and the fiber node was responsible for 3.2%, which is the majority of things. Within a margin of error, that could be the one thing responsible for all of it, right? And so what we ended up, what we did as a first step is we took a threshold of 2%. So if any of the individual links in that path is responsible for more than 2%, we said that this is this is a critical source. This is something that we're going to flag in the fault isolation model. To your point, it could be the device, 2%, and then the fiber node another 2%, and then the rebuffer ratio is like 5%, right? So it could be multiple ones. But when we want to try and operationalize that, we then take the fiber nodes and go and work with the fiber node operations team, and then we take the devices nodes and go work with the development team and say, these devices aren't performing. Kind of a high level approach. So the fork out point is when we want to operationalize these metrics, we have to decouple things and say anything that's contributing to more than 2%, this, to some degree we can be confident that it's contributing. Does that answer your question? Okay, great.
So besides the rebuffering ratio, have you done a similar study for video quality of detecting it? And what are your findings?
We did some analysis that took in consideration rebuffering ratio and then startup latency or delay, which I think is what you're referring to. But startup latency is a little bit trickier for the simple fact that if you're playing a 4K asset, sometime your starting time is longer. If you're playing on a specific device, sometimes it's just it depends on the asset itself. In some cases, it depends on the CDN configuration and so on. So certainly, it's the next big thing on the list. If I go back here and one thing we said is expand the number of QA metrics to be produced and operationalized. That pretty much is in line. That would most likely be our second one. Except we thought that rebuffering ratio is probably the easiest to interpret and build on. Next steps, yeah. Other questions? Everyone want to go on a break? All right, well, hey guys, thank you so much for being here, and I appreciate it. Thank you.